So this first statement is certainly correct. We have to convince ourselves by going through the calculations. Once again, keep in mind that 2 to the power 20 is about 1 million. So 2 to the power 24, which of course you can write as 2 to the power 4 plus 20, is 2 to the power 4 times 2 to the power 20. So that's 2 to the power 4 times a million. 2 to the power 4 is 16, and that's about 16 million. So you can see it can be helpful to get a quick sense of how big these numbers are. And our friend has demonstrated they have understood this concept well, that with 24 bits, you can represent about 16 million different colors. Now for the second statement, our friend says that this number, 2 to the power 81, this large number, is represented using 81 bits. Our friend is remembering something we said on the previous slide, that with k bits, you can name 2 to the power k different things. But that statement is not the same as saying that it takes 81 bits to represent 2 to the power 81. In fact, if you ask the Python REPL, how many bits does it take to represent this integer, rather than typing it all out, I'll just say take this expression and then dot bit length. This dot bit length is a built-in method or a way of querying some information about this int. We're basically saying, for this int, tell me this int's bit length. So this dot is read a little bit like apostrophe s. Tell me this integer's bit length, and the REPL tells me that it takes 82 bits. So our friend was nearly right, but more importantly, our friend has confused two closely similar concepts. If you need to represent 2 to the power 81 different items, you will need 81 bits. But to represent this particular integer, this integer in binary, if you work it out, is 1 followed by 81 zeros. So that's a total of 82 bits. There's a slight difference between those two statements, and our friend did make that error. On the other hand, this statement is of course perfectly true. So there are integer values that you can compute with in Python using the int data type, which is available in the Python language. And although there is a data type with exactly the same name in the Java programming language, because that integer type in Java is restricted to only 32 bits, Java cannot represent integers as large as this. In fact, if you have 32 bits, then you can only name 2 to the power 32 different integers. And if you quickly work out how much 2 to the power 32 is, that's roughly 4 billion. Why? Because 2 to the power 30 is 1 billion roughly, and 2 to the power 31 is 2 billion, and 2 to the power 32 is 4 billion. So there are only 4 billion distinct integers that you can represent in Java. Now it turns out that exactly half of those integers, roughly 2 billion, represent negative integers, and the remaining represent non-negative integers. So roughly speaking, the biggest integer that you can represent in Java is plus 2 billion, and the smallest one is roughly minus 2 billion. Java cannot represent such a large integer.